Alright, so Unit 4 review, question number 1 says simplify each expression. So when I ask you to simplify, we're wanting to see if we can factor anything so that we can cancel parts out. So when you look at the numerator of this fraction, the first thing I notice is a quadratic. Every time you're given a quadratic, first look for a greatest common factor. In this case, there isn't one. And then you put it into your asterisks. So when I put this into my asterisks, I have 1, 1, negative 15, and 1 times 54, which is 54. So what two numbers multiply to give me 54 and add to give me negative 15? So negative 9 and negative 6. 6 times 9 is 54. Negative times negative is positive. Negative 9 and negative 6 is negative 15. Here. Yeah. Close. That won't give you, your signs have to be wrong. Yep. So that gives me in the numerator n minus 9, n minus 6. What do you know about your denominator? So it's not a quadratic, so we can't use our asterisk. What else can you do with it? Not going to work. N's not squared, so you can't do that. So the only thing you can do with the denominator, since the n's not squared, you can't use the difference of squares, only thing you can do is factor out a greatest common factor. So there is a number that goes into 4 and 36. You know 2 does because they're both even. Even bigger than that, 4 works. So if I take a 4 out, that leaves me in my parentheses n minus 9. Now what can you do?
Cancel the n minus 9.
Yep. So you should be able to cancel something. The n minus 9 on the top cancels with the n minus 9 on the bottom and leaves you with an answer of n minus 6. You don't have to write that in parentheses, but you can, divided by 4. And that would be my final answer. Questions on number 1? Number 2 is kind of the opposite. Now we have a greatest common factor on the top, a quadratic on the bottom, in which we'll have to use our asterisks. So looking at just that top part, what's the greatest common factor? So first thing I want to know is the number. What goes into 9 and 36? Bigger. 9. If I have m squared in one term, m in the other, do you pick the bigger exponent or the smaller one? The smaller one, so I'm picking m to the first or just m. If I factor that out from both terms, that leaves me with m minus 4. The denominator I'm going to put into my asterisks. I'm looking for two numbers that multiply to give me negative 40 and add to give me 6. Since that 40 is negative, I know my signs have to be opposite, so one of them needs to be negative, one of them needs to be positive. 4 and 10, which one needs to be negative? 4. So negative 4 plus 10 gives me that 6 that I'm looking for in the denominator. Right. So that factors into m minus 4 times m plus 10, and then what can you do? Cancel out the m minus 4s. Leaves you with a final answer, of 9m divided by m plus 10. We good on the first two? Benji's good on the first two. All right. Moving on to question number 3. So question 3 asks you to simplify this expression. You have to use your asterisks how many times?
3.
Tiana? Oh, is that Melissa? Is that you? Yep. 3 times, and there's 1 time you have the greatest common factor. So looking at your first fraction, the numerator, what did you get that to factor into?
X minus 9x minus 4.
I'm going to use k's because that's what's in the problem. But
Oh.
so k minus 9, k minus 4. If you have x's, that's fine. I'm not going to take off.
I have k's in.
Oh, okay. So use your asterisks. 2 numbers that multiply to give you 36, add to give you negative 13, negative 4, negative 9. For the denominator, greatest common factor this time, factor out a k, leaves you with k plus 8. Move to your second fraction. So in my asterisks, I'm looking for 2 numbers that multiply to give me negative 40, add to give me 3. Say that again, Tianta.
It's negative 5 and 8.
Yep. So k plus 8, k minus 5, order doesn't matter. If you have them in opposite order, is fine. And then your denominator, 2 numbers that multiply to give you 20 and add to give you negative 9.
Negative 4 and negative 5.
Now what are you going to do? Cancel stuff out. Remember, you always cancel things in pairs. They have to match exactly, including the signs. So give me 1 pair you can cancel out. The k minus 5s cancel. K minus 4 cancels. And the k plus 8 cancels. So that leaves me with, in my numerator, k minus 9. In my denominator, leaves me with k. Can I cancel out those k's? No, absolutely not. The top one is being involved in a bigger picture. So it's k minus 9. Can't cancel that k out.
Where did you get the first denominator from?
Factored out of greatest common factor. So the denominator here, they both have k's in them, so take one of them out. What's left goes in parentheses.
Okay.
So final answer would be letter A. So for questions 4 and 5, we are going to multiply for question 4, divide for question 5, and then we're writing our answer in lowest terms. That just means cancel out as much as possible. So for question number 4, it's exactly like question number 3. We need to go through and factor things. So looking at my numerator, if I put that in my asterisks, I need 2 numbers.
B minus 2 and B plus 2.
Yes. B minus 2, B plus 10. What do you notice about the denominator? You can do something with it. So it's a difference of squares. Because they're both perfect squares with that minus sign in the middle, that's where we get those 2 sets of parentheses, 1 plus sign, 1 minus sign. Square root of b goes first. Square root of 100 which is 10, goes second. So that breaks up in two sets of parentheses, plus sign and a minus sign in the middle. Square root of the first term first, square root of the second term second.
And you can only do that when it's something like a letter square and then
Minus. Has to be a minus sign. If that was a plus sign, we couldn't do it. What's that, Benji? So, square root of both terms.
Well, what was last line? So that's one person.
For the second fraction, what do you notice about the second fraction?
2b minus 2 and 2b minus 1. What do you notice as a 2 right there?
So, this one has a leading coefficient. That first number's there. Do all the other terms have a 2 in them? Like, can you factor a 2 out of all those terms? So, you want to take a greatest common factor out of this right here. So, there's a greatest common factor there. It's going to make all your numbers smaller. So, when I factor out a 2, it leaves me with b squared minus 11b plus 10. And then I want to put this into my asterisk. So two numbers that multiply to give me 10 and add to give me negative 11, negative 10, and negative 1.
I have a question.
Yes.
If you didn't factor it out, will you get the same answer?
No.
You have to factor the 2 out
Yep.
first.
Because your 2 will get lost.
So exactly where does that 2 go?
So it goes out front of your parentheses.
Right.
So we factored it out and it's just going to sit out there until later. And then we'll do something with it later.
Okay. I was ahead of the game and now I ain't ready.
For the denominator, 12b minus 12. First thing you're looking for, is there a greatest common factor? So you're going to factor out a 12, which leaves you with b minus 1. And now we want to go through and simplify everything that we can. So give me one pair of parentheses that I can cancel. B minus 10s cancel. The B plus 10s cancel.
How did you get the minus 1 on the bottom denominator of
The second one.
Yeah.
So we took out a 12.
Right.
So I took 12b divided by 12 is b. Negative 12 divided by 12 is negative 1. So remember, when you do greatest common factor, in your parentheses you should have as many terms as you started with. So we started with 2 terms, we have to have 2 terms in our parentheses. Yep. And then cancel out those b minus 1s. What do you know about this fraction right here? It reduces. So that 2 and that 12 is going to reduce to give you 1 over 6. Which means all that's left in the numerator is that 1. Well, multiplying by 1 isn't going to change anything, so we really don't have to write it. So b minus 2 divided by 6. So final answer for this one, b minus 2 over 6.
So for that first one, you got to cancel out both the denominator?
We canceled them both out, yeah. So anytime you have something on the numerator and the denominator, you can cancel it. So these b plus 10s canceled, the b minus 10s canceled over here.
Can they be on the same fraction?
Yes. Yes, they could be on the same fraction like the b plus 10s, or they can be on different fractions like the minus 10s. Yes.
We'll get points off for not breaking that down. Because I had it, but I still kept it.
He'll get partial credit. Like, you're not gonna miss all the points, but you're not gonna get all the points either.
Can you explain to me what you did for
Here. So these, all 3 of the terms in the numerator of that second fraction have a common factor of the 2. This yellow part, we just put it in your asterisks.
I already know that. I'm asking for, like, since on the first fraction I canceled out b plus 10 minus 11.
Why do you have a b minus 11 though?
Oh wait,
Yeah, so the 1s will cancel.
Alright,
Alright. Alright, so question number 5, we're going to use similar process for question number 5. First thing I notice about this problem, though, it's division. So remember, when you have a division problem, keep, change, flip, keep the first fraction the same, change the division to multiplication, and flip the second fraction. So we want to actually solve, whoops, this problem here. So if it helps you to rewrite it like this, keep first fraction the same, change that division to multiplication, and then flip that second fraction. And then you want to factor everything. So looking at the first fraction, I see there's a greatest common factor of 6.
9.
Yep, so p minus 9. And then for my denominator, there's a greatest common factor of 8. So my first fraction simplifies to this. For the denominator of the second fraction, going to have to use our asterisks. So two numbers that multiply to give us 18 and add to give us negative 11.
Which is 2 and 9.
Negative 9 and negative 2. So I have factors p minus 9 and p plus 2.
No, minus 2.
Oh, yes, you're right. Thank you. So now you want to cancel anything possible. The plus 9 cancels. The minus 9 cancels. Anything else you can do?
You just
Yep.
get plus 9 from. Oh, you switched it.
Because it's already right there, you can't do anything with it,
Yep.
so you keep it the same.
Why just switching?
Because it's
Like flip the fraction, is that what you're saying? What are you asking, Lindsay? So this flips here because you change the sign. So since it's division, you change it to multiplication and you flip that second fraction upside down. And then you can multiply it like we did on question 4. So then we'll reduce the 6 over 8 to 3 over 4. Leaves me with a 3 in the numerator, a 4 in the denominator, and a p minus 2 in the denominator. So this would be my final answer. So we've canceled and simplified everything possible.
So whenever you're dividing and multiplying fractions and stuff, you always leave what's on the bottom at the very end.
Whatever's left stays there. Yeah. Alright, next page. Question number 6 says simplify the expression. Here we've moved to addition. When you have addition, you have to have a common denominator before you can add or subtract fractions. So looking at this, I noticed that the second fraction is a difference of squares, and if I factored it, it would be t plus 3 times t minus 3. So since both of those terms are something squared, minus sign in the middle, it breaks up using that difference of squares. So since t is squared, there's a minus sign, and then 9 is a perfect square because 3 times 3 is 9. We break it up into two parentheses using t and 3.
It goes away.
Yep, so we essentially just separated those t's. Yep. So now this actually is going to be our greatest, or our denominator, our least common denominator. So what do we have to multiply that first set of parentheses by? What's missing in the denominator of the first set of parentheses? Or the first fraction? The t plus 3. So you're going to have to multiply this first fraction by t plus 3 divided by t plus 3. So when I multiply the numerator, I have to distribute this 5. So 5 times t is 5t. 5 times 3 is 15. Plus, that second fraction, the numerator is 4. We don't have to multiply that second fraction by anything. And then we're going to bring down our denominator. So since we had that common denominator now, we just put them together into one big fraction. And then to simplify this, all you need to do is combine your like terms. So I'm going to combine like terms here, leaving me with 5t plus 19, which is letter A. Denominator didn't change.
So you always just multiply the top number by the bottom number?
By whatever's missing from the bottom. So like the t plus 3 was missing from that first denominator, so we had to multiply the top by it. Question 7 and 8. So question 7 and 8, we are adding and subtracting fractions. Have to get a common denominator first. So looking at question 7, I need to decide what my least common denominator would be.
Number 7,
Mm-hmm.
12, xy is second.
You could do that. Or you could do 6. So I would do 6 because 6 divisible by 6 and 2 goes into 6. You can do it that way, you'll just have more reducing, Melissa. So I would do 6xy squared as my common denominator, which means when you look at that first fraction, what is missing from the denominator? If I have 6x, I'm looking for 6xy squared.
Just the y squared.
Just the y squared. So I'm going to multiply by y squared on the top, y squared on the bottom. Then I'm going to look at that second term. I have a 2y squared. I'm looking to get a 6xy squared. What do I need to multiply by? 3x.
How'd you get the 3x on the other side?
Because 2 times 3 gives me the 6 I'm looking for.
Okay.
And then that x is missing. Yes.
Okay.
I feel like I've been understanding all the other problems, but these last two, I'm just.
So we're trying to find the least common denominator. So remember, when you add and subtract fractions, the denominators have to be the same. So when we look at this, I have to decide the smallest number I can that I can get into 6 and 2. So 6 is divisible by 2 and 6. So that's why we picked the 6, and then any variable that's in either one has to be part of your common denominator. So then when I looked at this, I had 6x. Well, that's here, but I'm missing this y squared. So that's why we had to multiply that first set of that first fraction by y squared.
Where did the 3 come from?
So when we get here, we have a 2, we want a 6, so we have to multiply by 3. And the x is missing.
You just have to do to the top.
Mm-hmm. Yep, if you do something to the top of, or the bottom of a fraction, you have to do it to the top, because that keeps it equal. Say that again.
It's common.
That's what we want our least common denominator to be. So once we get here, we're going to simplify. It gives me 4y squared for the numerator of the first term. Plus multiply that second thing. We're taking 5x times 3x. 15 what? Yes. So 15x squared. X times x gives us that x squared.
But if you get 3x to multiply by.
Because you have to make that 2y squared become a 6y squared x. X squared.
Why?
Because
Because
our
they
denominators
be
have to
the
match.
same.
So they both have to be 6xy squared. So we had to take that 2, multiply it by 3, so it became 6. So 4y squared plus 15x squared divided by 6xy squared, final answer.
How did you get the 4y squared on top?
So we had to take that first fraction and multiply it by y squared
So whatever you do to y squared, you have to do that.
on top and bottom.
So that would make the bottom xy squared basically.
So it had an x. We wanted that y squared to be there, so we multiplied top and bottom by y squared.
Well, initially I was trying to put xy on top as well.
Nope, because x is already in the bottom, so you don't have to add it again. All right, question number 8. So for question number 8, I'm looking at my two denominators, and I'm realizing they don't really have anything in common. One's x plus 4, one's x plus 3. If it helps you to think of those as two things in parentheses, that's fine. My least common denominator is going to be x plus 3, x plus 4. So since nothing matches, you got to put them both in there. So then what's missing from the denominator in the first term?
X plus 3.
Yep, so you're going to multiply top and bottom by x plus 3. What's missing from the second term? Yep. So we're going to take the first fraction, multiply it by x plus 3, second fraction, multiply it by x plus 4. Since this one's subtraction, your parentheses are really important. When we distribute, we're going to distribute the 7. When you distribute this 4x, distribute the negative with it. So 7x plus 21 minus 4x squared minus 16x. Denominator again stays the same, x plus 3 times x plus 4. And then when I combine my like terms on the top, I want to write things in descending order. Always start with that biggest exponent first. So biggest exponent I see is the 4x squared. Make sure you bring the negative down with it. So negative 4x squared. Then I have a negative 16x and a positive 7x. It gives me negative 9x plus 21. And then my denominator stays the same, x plus 3, x plus 4. And that's it.
No extras?
No.
Is there no asterisk on this one
No.
because you're just trying to put them together?
And it doesn't factor, I don't think.
How do you do it like that? At the bottom?
The bottom stays the same. So once you decide what your least common denominator is, it stays that all the way through. So our bottom's just these two things multiplied together.
I'm saying, like the top.
This right here?
Yeah.
I brought this term down. I combined the 7x and the negative 16x, because they're like terms, to get this negative 9, and I brought down the 21. Alright. Question 9 is what we did yesterday. So now we have an equation with a bunch of fractions in it. Easiest way to do it is to find out what the common denominator is, and multiply by it. So here, first thing we have to do is factor that first fraction to figure out what the factors of the denominator are. So if I put this into my asterisk, I need two numbers that multiply to give you negative 20 and add to give you negative 1.
5 and 4.
5, 4. That doesn't give you 1. The multiplies to give you negative 20, but it doesn't give you 1. So negative 5 and positive 4 multiply to give me negative 20. When I add those two numbers together, I get negative 1. So that, since the x minus 5 is the denominator of the second term, x plus 4 is the denominator of that right side, that would be what our least common denominator is. So we want to take and multiply every single term by our least common denominator. So I'm going to take every term, multiply it by x minus 5, x plus 4. Oh no. Oh, I just erased it. Alright, so when I take that first fraction and I multiply by x plus 4 and x minus 5, what's going to happen?
Change or whatever.
Nope. So I have that x minus 5 now on the top and on the bottom. What can you do? Yep. So you're going to cancel. Same thing with the x plus 4s. They're going to cancel as well. That leaves you with just 5. Bring down your minus sign. What happens on your second term?
The x minus 5 cancel.
Yep, the x minus 5s cancel. That leaves you with 1 times x plus 4.
1x plus 4.
Yep,
Negative. Can you change it? Does it
you will, yes. You'll have to change it. And then on your last term, the x plus 4s are going to cancel. Leaves you with 1 times x minus 5.
You got the bottom right there off by asterisk.
Mhm.
X minus 5.
And then we just multiplied every term by that, because something has to cancel in all of them. So now we want to distribute this negative 1. So 5 minus x minus 4 equals, distribute this one, x minus 5. So now we just want to get x by itself. Could go a few different ways to do this. What do you want to do? Give me some.
Move the 5.
Move the 5. Which one?
The one or the bigger one that you drew. I bet the small one.
Oh, use it. Whatever. That way or the other way?
Didn't you say get the x by itself?
Yeah.
The x's with the numbers?
There are 2 x's, so it doesn't matter.
Well, I was trying to move that one over there.
Oh, so you were doing it the other way. Alright, so subtract 5 from both sides if you're doing it that way. Leaves you with negative x minus 4 equals x minus 10. Add 4. Negative x equals x minus 6. Subtract x. Oh, this is negative 2. So negative 2x equals negative 6. Divide by negative 2. And x equals positive 3, which is letter C. So answer letter C.
Can you distribute for the very first portion of that?
Like the negative 1?
Like whenever you have 5 over x minus 5, x plus 4.
So here we cancel the x minus 5 out with the x minus 5, x plus 4 with x plus 4. That's what left us with that 5. So we didn't have to distribute.
So basically,
Here we had to take the negative 1 and distribute. We just did it the next line.
use my real quick.
on top. So if you're gonna multiply every term by x plus 2. So we're gonna multiply 5 times these two things, but this cancels out with the x minus 5 down here. This cancels out with x plus 5. So that leaves you with just this. So this is that term is coming from. Is this factor with this? Just put circle it and we'll go back to it. Alright. Question number 10. Another equation. Have to find that least common denominator. What is it? 2r. So I want to multiply every single term by 2r. So looking at that first term, if I multiply it by 2r, something should cancel. What is it? The 2's cancel, leaving you with 5 times r, which is 5r. So my least common denominator is going to be 2r.
Why is it 2r rather than just, because they don't all have the 2 and the r?
So the least common denominator for this would be 2r. Because these have r's and then these have 2's in them, so I have to have them both in my least common denominator. So that's what I'm going to multiply by, because when I multiply that, something cancels in every single term.
Okay.
So the 2's are going to cancel in the first term, the r's will cancel in the second, and everything cancels in that third.
Okay.
Because it gets rid of all those fractions. Yes.
Why are we on the top of the
Because that cancels out our denominators. Because we're canceling out all these fractions to get rid of them. Is essentially what we're doing. So we're left with no fractions, just all whole numbers.
So when you cancel, you can take the 2 away from the r to cancel the 2 on the bottom there?
Because it's like 2 times r.
Okay. Okay.
So the next term you're going to cancel out the r's, not the 2, because there's no 2 in the denominator.
If you need me, I'll be cutting.
Okay. And then we're going to take 2 times both the terms that are in that numerator. So 2 times r is 2r. 2 times 2 gives us that 4. So we had to take that 2, multiply it by both terms in that second numerator.
The whole thing cancels out the bottom.
Yep, the bottom cancels out with the 2r, leaves you with r minus 7. We did that last term gets multiplied by 2r, but since there's 2r in the denominator, they just cancel each other out. We don't have to because it cancels. If not, you just distribute it.
So 2 are automatically canceling.
Yep. Because this cancels out all of our fractions. So all of our fractions are gone. We're just left with a multi-step equation. So here I would combine these two terms. They're both on the left side of my equal sign, so I just put them together to get 7r. Yep. So then I would subtract r from both sides. So 6r plus 4 equals negative 7. Subtract 4. 6r equals negative 11. Divide by 6, and r equals negative 11 sixths.
You move the 4 over.
Yeah.
Okay.
And then I divide it by 6.
I got confused with the fraction. I thought I did something.
Nope. Fractions are okay. Yes, they are. Alright, question number 11. We have Adam who can mop a warehouse in 8 hours. Wilbur who can mop the same warehouse in 12 hours. If they work together, how long would it take them?
I don't know what she's giving us a break. She doesn't give us breaks.
Oh, how many tests we got out there?
I don't know. I'm gonna say 1.
Final?
1 and then the final. I don't know yet.
Was it here from yesterday's?
Well, this is from yesterday's lesson,
Yes.
right?
So here's where we make our fractions. What's your fraction for Adam?
Adam cooked mop in 8 hours.
Mm-hmm.
So A over 8.
You're doing A over 8? Plus, why don't we do
Wilbur.
T over 8? Didn't we use T yesterday?
Yeah. But my piece is like nothing,
Alright, we'll use A's then. And then Wilbur, we have to, but that A makes it confusing. I'm using T's. I'm gonna use T's. And then Wilbur does it in 12 hours, and we want to know
Equals 1.
how long it takes them to do one whole job. I missed it.
I said equals 1.
Oh. What's your least common denominator? Smallest number that's divisible by 8 and 12.
2, 3. No.
You're doing multiples, not denominators. So I need a number that I can divide by 12 and I can divide by 8.
4. I said 2. That's not big enough?
It's got to be bigger than 8 and bigger than 12.
8.
I can't take 12 and divide by 8.
Wait, what? It's got to be bigger than 12?
I have to be able to divide it by 12.
24.
24. Woo. So I want to take every single term and multiply it by 24.
Why do it have to be bigger?
Because you got to be able to put.
Because I have to be able to reduce both the 12 and the 8. So when I look at 24 divided by 8, 24 divided by 8 is 3, right? And the t comes down with it. For that second fraction, we're going to take and multiply t by 24 and divide by 12. Well, 24 divided by 12 is 2, so 2t. And then 24 times 1, 24. That gives us 5t equals 24. Divide by 5 and t equals 4.8. So in a sentence, you're going to tell me it would take 4.8 hours for them to mop together.
When you do it, do you do the top as in together or the bottom as in? Oh.
Yes. So remember yesterday on that assignment, they gave us, hey, it took them 3 hours to do it together, and that's what we put on the tops.
Okay.
Oh, man. I forgot it is break time.
Yeah.
All right, so we'll stop there, take a 5-minute break, and move to question 12. All right, so question number 12, working together, Jessica and Jill can install a new deck in 9 hours. Had she done it alone, it would have taken Jill 21 hours. How long would it take Jessica to do it alone? Be sure to respond in a complete sentence. Blah, blah, blah. So the way I do this might be a little bit different than the way Melissa did it. I don't remember how Melissa did it yesterday. But when I do it, I do the total time that it would take them to do it together, which is 9 hours for both of my fractions.
That's what I did.
And then for my individual times, I know it would take Jill 21 hours. And I'm trying to figure out how long it would take Jessica to do it by herself. And then again, we want that to equal the whole job getting done. So here for my least common denominator would have to be 21 and my variable. So 21j would have to be what I multiply by. So on my first fraction, the 21s cancel, leaving me with 9j. Whoops. Plus, for my second term, my j's cancel, leaving me with 9 times 21, which is 189. Bring my equal sign down. 21j times 1 is 21j. And then I want to take this equation, I just want to solve for j, so I would subtract 9j from both sides, which gives me 189 equals 12j. Divide by 12 and learn that it would take Jessica 15.75 hours. So in my sentence, I would just write, it would take Jessica 15.75 hours. So again, it doesn't have to be a long sentence, cut to the chase.
Where did the 9J go? You got 9J plus 189.
I subtracted it. Here. So I subtracted 9j from this, subtracted 9j that. That's why that changed to 12.
Oh, okay.
I just didn't write my step down. I was being lazy.
I was thinking for some reason they were both 21.
No. You're good. Yeah, so I subtracted 9j.
Oh, no, you did.
I skipped a step. I know.
No, don't talk about
Oh.
that. Like, it's the next
Oh, I haven't flipped the page.
one. Yeah.
Oh, yeah, we did. Long division, here we come. All right, question 13. Again, Melissa's told you this question's on your test. You have to use long division. You can get partial credit for it. Partial credit's better than no credit. So set up my long division. I'm going to take, I better write that down further. B minus 10 is what I'm dividing by. And I'm dividing b to the third minus 6b squared.
The one on the test is going to be it's going to have the 3. I guess she's
It'll be like this, I think.
She's not going to do it just by the second power.
I don't think so. It's going to be just like this. So it'll be this long. It's only like 3 steps, though. Like, you have to repeat that cycle 3 times. So I remember Melissa taught this a little bit differently when she did the do now. She took b to the third and divided it by b. So first term underneath your division bar divided by the first term out front gives you b squared. So then you're going to multiply b squared times b to get b to the third. B squared times negative 10 to get negative 10b squared. Those go in parentheses, and then we're going to subtract. Remember, Melissa said she suggests that you follow that keep, change. So keep the first line the same, change the subtraction to addition, and then all the signs in your parentheses change. And then you're going to add straight down. B squared, or b to the third minus b to the third cancels. Then you have negative 6b squared minus plus 10b squared gives you 4b squared. Bring down your next term. Repeat the process. What times b gives you 4b squared? 4b, positive 4b, and then I'm going to multiply. 4b times b is 4b squared. 4b times negative 10 is negative 40b. And then we're going to subtract. Again, change, keep the top row the same, change the sign to addition, and then all the signs in the parentheses. So my 4b squareds are going to cancel. My negative 44b plus 4b gives you negative 4b. 40 and 4b. And bring down your last term. So for my last cycle, I need to figure out what times b is negative 4b. Negative 4. So I'm going to multiply negative 4b. Negative 4 times negative 10 is positive 40. Then we're going to subtract. Keep that top row the same. Change your subtraction to addition and all the signs in your parentheses. So now my 4b's will cancel because one's positive and one's negative. Now I have 34 minus 40, which is negative 6. Say that again. Yep. So your remainder is going to be that negative 6. So if I write my answer, b squared plus 4b minus 4 minus 6 divided by b minus 10. And that would be my final answer. And Melissa said you can just write it up on the top with the rest of your answer if you want. I just wrote it out to the side so it looked nicer. When I'm done. Questions on 13? I can't get in my cabinet. All right, question 14 is where we get to use synthetic division. So synthetic division, we have to have all of our coefficients across the top. Make sure you have every degree accounted for. So after this 5 into the third, I have to have n squared next. So 55, then n, which is 49, and then my constant, negative 17. Remember, it's always 3 rows down. How do you determine your magic number that goes outside your box? So set n plus 10 equal to 0. Well, if n plus 10 equals 0, what does n have to equal? Negative 10. So my magic number is negative 10. What are you going to do with that negative 10? Multiply. So bring that first coefficient down. So bring the 5 down. And then you're going to multiply. 5 times negative 10, negative 50. So that goes in the first open or available middle box. Then what do? 55 minus 50, which gives you 5. Repeat. Multiply. 5 times negative 10. Negative 50. Add again. What's 49 minus 50? Negative 1. Multiply. Negative 1 times negative 10. Positive 10. And then add these together again. Negative 7. That last number is going to be what? Your remainder. Somebody tell me what their answer is. So read me your answer. Yep.
minus 5, n minus 1, r minus like number itself over n over 10.
I didn't get that far.
Negative 7 over n.
I got you.
What is this?
Something you were absent for.
So,
This is easy.
one less than.
Yes. So your answer's always one exponent less than. So if you start with x to the third, your answer's going to have x squared as your first term.
If you start with n to the fifth, it'll be n to the fourth, and you
Yeah. So if I give you, which is not going to happen, x to the 12th, your answer's going to start with x to the 11th. It's always one less than.
This is way easier than that.
So you're telling me you want to do long division on the next one?
No. Heck no.
All right, so question 15, there's only one little tricky thing about question 15. Anybody know what it is?
You get to pick. What's
All of
tricky
it.
about it? Oh, I know what's tricky.
What is it, Tiana?
It's missing to the second page.
Yep. So this is missing that term right here, well, with the m squared. What do you put in there?
0.
0. So when I write my coefficients, Tianta's determined that we have to use synthetic division for this.
Yeah.
So we have a 1, a 0, a negative 12, and a negative 19. What's your magic number? 5. +5. So bring that first coefficient down. And we're going to do exactly what we did on that last question.
So it's which one's what?
Look, you already know what you're doing. Then what? Then what?
And then 0 minus what?
Plus.
Oh.
So you add them,
Oh, yeah.
because they're both positive. And then what?
I don't know.
Repeat the process.
Just bring a 5 over again?
No, you gotta multiply.
Multiply.
Multiply. So when I multiply, I'm going to get 25. Add to get 13. Multiply to get 65. Add to give you 46.
Okay, so what are the bottom numbers?
So all of these numbers here in the bottom are the coefficients of your answer. Last one's going to be your remainder.
So she multiplied them ones to the 5
Mhm.
to get the next one.
Yep.
Okay.
So for my final answer, I'm starting with 1m squared plus 5m plus 13 plus 46 divided by m minus 5.
Yeah.
At least you guys go.
That is so easy. Multiply, add, multiply, add, multiply, add.
I tried
That is so easy. Would you rather do this?
I'll help you later.
One
Because
of
that x
and
squared.
then the rest.
You have to put the 0 in.
She said one like this,
Uh-huh.
one like this, and then you get to pick which one, and who's gonna
Would it be
pick
0
one?
x squared?
Huh?
No.
You.
Yeah.
Oh, nice.
You better pick this
That's
one.
too much.
This one is easy.
Questions on this one
I'm gonna do it.
before you two start fighting?
And then you go pick all your stuff. She said she's gonna do that one, the long division. You're gonna get 1 point, and that's because your answer is right, but you're gonna get
All the other points, yeah.
It's 5 points. What question? 5 points?
Most questions.
Oh, I think it's only 3. All right, question 16. The problem below is solved incorrectly. Describe the mistake and find the correct answer. So when we have these problems, I always tell my students, hey, solve this problem on your own before you look at what they did so you don't make the same mistake they did. So if I would give you this problem, what would your first step be?
Add 5.
No. Yes.
So I'll agree that something has to be done with the 5. What is that negative 5 doing to that square root?
It's just like 1.
It's in the way. Is it being added, subtracted, multiplied, or divided?
Multiply.
Multiplied. So that negative 5 is being multiplied by that square root, so we want to do what? Divide. So we're going to divide both sides by negative 5. So these cancel. So now I have the square root of 3r minus 4 equals 4. Have we solved for r?
Oh, no.
So we're trying to get r by itself. How do we get rid of that square root? Square it. If you square one side, what do you have to do to the other? Square it. What happens on the left side when you have the square and the square root?
It takes that all.
Yep, they cancel each other out. They're inverses of each other. It's like adding 12 and subtracting 12. They cancel each other out. So now I have 3r minus 4 equals what? 16. Add 4. So 3r equals 20. Divide by 3. And r equals 20 over 3. No. So on your answer line, I didn't scroll up far enough to get that answer line on there. But on your answer line, write r equals 20 over 3. Then we have to figure out what they did wrong.
They subtracted the 5 instead of multiplying.
Yep. So you're going to tell me in step 1. So, they added the 5 when they should have divided. Questions on this one? You good?
Yeah, my hand's
Do we have to check our estimate being?
For the next one, yes. Alright, question 17. So we want to solve this equation for b. What do you have to do first?
Get rid of the radical.
Yep, so since our radical is on the right side by itself, we can just go ahead and square both sides. That gives me b squared equals, and then on the right side your square root and your squared cancel, so negative 18 plus 11b. Now since we have a quadratic term, we have that b squared, we need to move everything to one side because we know we're going to have to factor it, put it into our asterisk.
So b plus b squared plus 11b.
Minus 11b.
Yep, I said that. Plus 18.
Yep. So b squared minus 11b plus 18 equals 0. We added the 18, we subtracted the 11. So now I'm looking for, whoops, that's a positive. Two numbers that multiply to give me 18 and add to give me negative 11. Close.
36.
Further away. How about negative 9 and negative 2? Got Oh, okay. Got you. I know what you're doing now. So that gives us factors of b minus 9, b minus 2. How do you get your solutions? So set them both equal to 0, which means b equals 9, b equals 2. Remember, anytime you get two answers, you need to check for extraneous solutions. So we have to take both of these numbers, go back to the original, and plug them in. So if we take 9 and we plug it in, I would have 9 equals negative 18. So if I plug this in here, 9 times So 9 times 11 gives you 99 minus 18 gives you 81. So really this is 9 equals the square root of 81. Well, what is the square root of 81?
9.
So does 9 work?
Yes.
Yes. So 9's not extraneous. Go back and check 2. So here, 11 times 2 is 22. 22 minus 18 is 4. What's the square root of 4?
2.
2. So actually, both of these work out for this problem. Doesn't mean that'll be the case on your actual test.
It's not going to be like that.
I will not confirm or deny whether they both work or not.
We just know
I'll tell you there's 2 answers on this question on your test tomorrow.
We just know it's not going to work because they want us to put them both in there to make sure.
We're not always trying to trick you, Tiarta.
Yes, you are.
No, we're not. We good on this? Alright. Question 18. How do you determine if a solution to a radical equation is extraneous? How would we know if one of those answers that we just got was extraneous? Plug it back in and what? What happens if it's extraneous?
It will equal.
It won't equal. So if you plug into the original equation and you get a false statement, it is extraneous. Do you want me to write that down for you? So if you plug into the original equation and get a false statement, it is extraneous.
How do you spell original? That didn't look right. I got it. So it's called extraneous if it does not work.
So extraneous, I think of the word extra. It's an extra answer that doesn't work. I wrote that correctly. Good?
Kind of with the word extraneous.
I have no idea. I'm sorry. Alright, we done with that page? Alright, last page. Oh, same thing. Alright, question 19. Solve the equation. Again, if you get 2 answers, make sure you check for extraneous solutions. First thing you have to do for these radical equations, get your radical by itself. Do you have to do anything to get your radical by itself? So we're worried about that square root being by itself. It's already by itself on the right side. So to get rid of it, what are you going to do? Square both sides. You have to be careful on this one. When you square this left side, you have to square the whole thing. So the n plus 2. And then when you square n plus 2, that's when you have to use that box. So that's when you're going to take n plus 2, n plus 2. Multiply it by its times itself. So I promise, if you write n squared plus 4, it's not going to be what we get. So a lot of times people want to take that 2 that's outside those parentheses and distribute it in. Not the same thing as doing your box. So that's going to give us n squared plus 2n plus 2n plus 4, which simplifies to n squared plus 4n plus 4. And then on the right side, your square root and your squared cancel. So all you have left is the 31 minus 2n.
Move it over, put it in your answer.
Move it over, put it in your asterisk. So subtract the 31, add the 2 in, gives you n squared plus 6n minus 27. So subtract the 31, add the 2 in to both sides. What's up? I saw you looking.
Where'd you get that extra 4?
This one?
Yeah.
So when we
No,
took
the
this,
other
we
one.
multiplied it together here.
The one on the very right, not the 4, just the 4.
This one?
Yeah.
Right here, the 2 times 2. Because this gives us, when we multiply this, we get a 2 in and a 2 in, and we add them together, which gives us the first 4, and then this 4 by itself.
Cancel out.
Nope, they're all positive. So nothing cancels. And we just add these two together to get those, get that middle point.
When you said equals 0, would that still be your answer?
We're not done yet.
Okay.
So now we're going to take this, and we're going to factor it in our asterisks.
N plus 3.
You're
N minus 9.
So two numbers that multiply to give us negative 27 and add to give us 6, 9 and negative 3. So n plus 9, n minus 3. So n equals negative 9, n equals positive 3. Can you just stop and be done? No, what do you have to do?
Chat was it.
Plug them in to make sure nothing's extraneous. No, so you're going to go back to that original. Anytime you see n, we're going to plug in negative 9 to start off. So negative 9 plus 2 equals the square root of 31 minus 2 times negative 9. Yep. I'll agree. Square root of 49. What's the square root of 49? Does negative 7 equal positive 7? Are they exactly the same? No. So that negative 9 is going to be extraneous. It doesn't work because negative 7 does not equal positive 7. You having $7 in your pocket is a whole different story than you owing me $7. Plug in the 3 just to check. So 3 plus 2 equals the square root of 31 minus 2 times 3.
Turned out to be extraneous. Oh wait, not extraneous.
No, I mean, it equals out. That works.
So 31 minus 6 gives us 25. Square root of 25 does equal 5. So the second one does work. We good?
So the only time it'll be extraneous is if both of them are not equal.
Like when we plug this in, we plugged in the negative 9, and we end up with negative 7 equals positive 7. So those aren't exactly the same, so they're not equal. The signs are opposite. Sometimes it'll be like 7 equals 12. Like, no, that doesn't work.
Well, only if it's extraneous is when both of them are not equal.
Correct. All right, questions 20 and 21. We want to rewrite the radical expression in exponential form. So for these,
It's going to be 10V.
10v, make sure when you write this, your 10v goes in parentheses.
And then it's
5 over 3.
I had to try to think of which one was on top of which one.
So I always try to think that 3 is a little bit lower than the 5, so it goes on the bottom. Like, not much, but it's a little bit lower. And then, again, we have to have those parentheses because if you don't put them there, it's assumed to just be with the v, not with the 10. That's why those parentheses are important.
Read over 2.
What number is sitting right in here that we don't write?
2.
The 2. So this is going to be 7x to the 3/2 power. Nope. All you have to do for these is rewrite them. No simplification needed. Same way with the next two. So the next two, we're going to go in the opposite direction. Yes, Samantha.
Where'd you get that to?
So since this is a square root, anytime there's no number written there, it's a 2.
Alright.
So like same way when we have an exponent of 1, we don't normally write it. Because square root's the most common, it's always that 2.
It's gonna show you a number two.
Yes. Alright. So for questions 22 and 23, we're going to go in the opposite direction. So what kind of root do I need for 22? Do I need the 5th root or the 3rd root? The cubed root, so the 3 goes right there. The 4k goes underneath. And what is your exponent? 5. Say that again.
It's gonna be the square root of 5, and you don't have to really write the 2 or the.
So the square root of 5n, again, we don't normally write the 2, and there's no need for us to write to the first power. So when I would write my answer here, I would just write the square root of 5n and be done. Like the 2's understood, the 1's understood.
She said prior that if you write it, it's like
Yeah.
no problem. You just don't have to write it.
Correct.
It's a 2 or the square root.
So the square root's the most common root that we see, so we don't write the 2 in there. It's understood. Power of 1 we see all the time, we just don't write it.
Okay.
Alright, questions 24 and 25, and then we're done. So question 24, first thing you want to do is rewrite this. So this is the what root?
Square root of 64.
3rd root. So the cube root of 64x to the 6th, what's your power? To the 5th. So since it wants me to simplify this, I need to take the cube root of 64.
I'll need the calculator so I can press the
forgot.
green button.
So on my calculators, remember the order's different. You're going to hit the 64, the shift button, the button that's right above the division, and then the 3.
I got 4.
Yes, should get 4. And then for your exponent, remember you take the number inside, divide it by the root, so 6 divided by 3 gives us 2. Bring down that exponent of the 5 because we haven't done anything with it yet. Now I'm going to take 4 to the 5th power. 4 to the 5th power gives me 1024. And then my exponents here, x to the 10th. So 1024 x to the 10th would be my answer, which happens to be letter A.
What did you get the 1,000?
So 4 to the 5th power.
Oh.
So in my calculator, 4 to the 5th power.
What did you take to get 64? The cube root of it. How do you do that on calculator?
So you're going to type 64.
And then you're gonna hit the
Second button. Right above the division sign. And then you type that 3 in there. So you have the 3rd root of it. I didn't mean to do that. And then we take that to the 5th power. So then that's when we use that. Yep.
4 to the 5th power.
So we're just going to hit this button again until it's in the 5th. You had a different number in your calculator. 4 I can help you in just a little bit. Let's finish this one, and then I can help anybody who needs help. So question 25, we're going to go in the opposite order. Now you have, oh no, we're not going in the opposite order, same order. Rewrite it. What root should you have? The fourth root of 81r to the 8th to the, again, 5th power. So find on your calculator, what's the fourth root of 81?
3.
It is.
R to the 2nd power. And then
Are we getting 3? Samantha's not. So on my calculator, you're typing 81. Right, 81. Then you get the green button, the shift button, the button that's above the division, and then the 4. And then equals.
Because they have the R.
I just thought something weird every time I do it because I get a weird decimal.
You have low and three in your nose.
What's that pretty?
Whenever you have like the square root right here, you can see it and then get translated.
Yeah. That's why we have to shift to go to the green.
That line has this too.
Oh. The exponents are different. When you deal with exponents, it's different. It's division to get it out, multiplication to go back.
And then you just divide it by 4.
Yep, and then R to the 8th, we're essentially taking 8 R's and dividing them into groups of 4. If I have 8 of something, divide them into groups of 4, I'm going to have 2 groups. And then I want to take 3 to the 5th power,
which is 243.
which is 243.
So,
R to the 10th is correct. Nice job.